Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI Stat, and CMI MSC Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
So let's start with problem number 15. It says that which of the following expressions take integral values for all integers n greater than 100? So basically these expressions we have to check, are they integral, or do they take integral values or not? So let's start with the first one, 3 to the n minus 1 by 2. So see, it can be done in various ways, but it can be done using the congruence modulo in number theory, which is very easy. But since we don't have that in the syllabus, we are going to use the very simple way. It's also quite simple. See, a to the n minus 1 divided by a minus 1 is actually nothing but 1 plus a square plus a cube up to a to the n minus 1, right? Where is positive. This thing, in fact, this is a is greater than 1. A is going to be greater than 1, right? See, this is nothing but the formula of the geometric progression, right? Of the summing of the first n terms of a GP. So this thing is true. This is an identity, right? So for a equals to 3, we can just put for a equals to 3, 3 to the n minus 1 divided by 2. This takes the form 3 to the n minus 1 divided by 2 is nothing but 1 plus 3 square plus 3 cube up to 3 to the n minus 1. Now this part is clearly an integer, right? A positive integer, because this individually these are all integers. So the sum is also an integer. So this entire thing is an integer. Now this is nothing but this part 3 to the n minus 1 by 2. So this thing is actually an integer. Therefore, no matter what n takes values of, this is true for all n, not just for n greater than 100. This is true for all n. So obviously, it holds true for n greater than 100, right? 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 So this part is true. So first one is actually does take integral values. So option A is true. So let's check the second option. Second option says 4 to the n minus 1 divided by 2. So see, 2 divides 4 to the n, right? Because 4 to the n is always even, so 2 divides 4 to the n. This is the symbol of 2. This denotes the symbol of division. So 2 divides 4 to the n for all natural numbers n, right? Now, since 4 to the n is even for all n, right? Now 4 to the n minus 1 therefore is odd for all natural numbers n, right? Because since 4 to the n is even, therefore 4 to the n minus 1 is odd. Therefore 2 does not divide 4 to the n minus 1, since this is always odd and 2 cannot divide an odd number, right? So this thing 4 to the n minus 1, this part is odd, divided by 2 is not going to be an integer, right? So this does not belong to the set of integers. So no matter what n takes, no matter what value n takes, this is not going to be an integer. So option B is not going to be the answer for this problem. Option A is going to be, but not B. So let's check option C. It says 4 to the n minus 1 by 3. Now again, just using this formula, this thing, just putting a equals to 4, we get 4 to the n minus 1 by 3 equals to 1 plus 4 square, and so on up to 4 to the n minus 1, which obviously, just like the previous reasoning, this thing is clearly an integer. This RHS, so obviously the LH is also an integer, right? So 4 to the n minus 1 by 3 is going to be an integer, right? Very easy. So this part, option C, is also true. Now option D says 5 to the n minus 1 by 2. Now see, 5 to the n is always odd, right? This is odd for all natural numbers n, right? So 5 to the n minus 1 is going to be even. See, 5 to the n, 5 to the 1 is 5, 5 to the 2 is 525, and 5 to the 3 is 625. So 5 to the n is always going to be odd. So 5 to the n minus 1 is even for all n. And since it is even, therefore it is obviously divisible by 2. So 5 to the n minus 1 by 2 is an integer, right? Very easy. It is an integer. So this again belongs to the set of integers. Therefore, 5 to the n minus 1 by 2 is, and it takes integral values. So therefore option A, C and D are all true. Option B is false. I mean option B does not take integral values. This one, option B. So A, C and D take integral values. Right? Very easy problem actually. We could have also used congruence modulo, but yeah, this is also quite simple to use, right? Very easy. So yeah, there you have it. The solution to this problem.
To book a trial class for your preparation courses of IITGM MS, ISIM Stat and CMI MSC Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists.